Find the degree of fulfillment, mu A, using the product inference. In this problem, a fuzzy rule-based system is provided using triangular fuzzy numbers, mu A1 through mu A4. Input values A1 through A4 are provided, as well as the premise statement of a fuzzy rule-based system, which is a compound logical expression of the fuzzy numbers, also called fuzzy arguments. To begin, we'll evaluate fuzzy numbers mu A1 through mu A4, and then return to evaluate to what degree of fulfillment the premise is satisfied. From the figure, mu A1 is the triangular fuzzy number 1, 2, 3. This means if A1 equals 2.0, then mu A1 of A1 would have a degree of fulfillment of 1. If A1 equals at most 1 or at least 3, then mu A1 of A1 would have a degree of fulfillment of 0. If A1 equals between 1 and 2, or between 2 and 3, mu A1 of A1 would have a degree of fulfillment varying linearly from 0 to 1, as A1 varies from 1 or 3 to 2. From the problem statement, A1 equals 1.5. And when 1.5 is mapped to triangular fuzzy number 1, 2, 3, the mu A1 equals 0.5. With mu A1 solved, we'll move on to mu A2, which is determined the same way. Mu A2 is the triangular fuzzy number 0, 2, 6. Since the value of A2 equals 4, and 4 falls halfway between 2 and 6, fuzzy number mu A2 also equals 0.5. The value of A3 is given as 4.8, which falls between 4 and 5, but is closer to 5, resulting in mu A3 with a degree of fulfillment of 0.8. Lastly, mu A4 evaluated at 3.0 equals 0.333. With the degree of fulfillment values calculated for fuzzy numbers mu A1 through mu A4, we can next consider the premise clause in the fuzzy rule-based system. At this point, we can substitute in the degree of fulfillment for each fuzzy number, and use the product inference to evaluate the logical expression and compute the degree of fulfillment for premise mu A. As the name suggests, the degree of fulfillment between two fuzzy numbers separated by an AND operator using the product inference equals the product of the degree of fulfillment of both fuzzy numbers. The degree of fulfillment between two fuzzy numbers separated by an OR operator equals the sum of the degrees of fulfillment of both fuzzy numbers minus the product of the degrees of fulfillment of both fuzzy numbers. Although unused in this problem, the product inferences for the NOT and XOR operators are shown here. Returning to the complex logical expression for mu A, we'll first solve the OR term inside the parentheses by applying the product inference for the OR operator and plugging in the individual degrees of truth. The quantity 0.5 or 0.8 computes to 0.9. Now, the expression for mu A is revised to 0.5 and 0.9 and 0.333. Next, the AND product inference is used twice. Once to multiply 0.5 and 0.9, which equals 0.45, and a second time to multiply 0.45 and 0.333, which computes to 0.15. When reviewing the possible solutions, the answer is B. In this problem, if we used the min-max inference instead of the product inference, this would result in a different degree of fulfillment. The product inference accounts for the fulfillment of all arguments, whereas the min-max inference only accounts for the limiting or extreme arguments in the premise clause. For example, in the min-max inference, the AND operator returns the minimum degree of fulfillment between the two arguments. The OR operator returns the maximum degree of fulfillment between the two arguments. And the XOR operator returns the maximum of the minimum of not the degree of fulfillment of the first argument and the degree of fulfillment of the second argument and the minimum of the degree of fulfillment of the first argument and not the degree of fulfillment of the second argument. Considering the same fuzzy rule-based premise as before, the OR clause inside the parentheses is first addressed. And the maximum value between 0.5 and 0.8 is 0.8. Next, the AND operator finds the minimum between 0.5 and 0.8, which is 0.5, and the minimum between 0.5 and 0.333, which is 0.333. When comparing the two degrees of fulfillment, we notice the difference made by the type of inference used when evaluating the degree of fulfillment of the fuzzy rule-based premise clause.